So type 1 error, type 2 error, type 1 error is false positive, type 2 error is false negative. I did use the notation, did I not, last time? Great notation. I didn't.
Yeah, I'm sure.
I should have. Did I draw that table last time?
Yeah.
Yes. If in reality you shouldn't reject and you perform a test, the test also concludes that you shouldn't reject. Did a mistake happen?
I don't think so.
You don't think so, or you know? No. Okay. If you do not, if in truth you shouldn't be rejecting, but you end up rejecting as your test conclusion, did we make a mistake? Yes. If so, what kind? Type 2. So negative, positive.
Wait, so the top, it's like rejecting or not rejecting the test result?
So the test result is either this or that.
Okay,
This is true.
okay,
So, for example, you have some sort of an illness, don't have the illness, you're just freaking out. You go and get a test. The test says there's nothing wrong with you, go home. No error. But if the test gives you positive when there is nothing wrong with you, did it make a mistake?
Yeah.
Yes. What kinds? The type 1 error or is it type 2?
so one.
It's type 1. In reality, something's going on, but the test ends with concluding there's nothing wrong with you. Go home. Did the test make an error?
Yeah.
Yes, type 2. Last case, of course, we don't have an error. So over here, this is a true negative, false positive, false negative, true positive. Good. Now, suppose you want to find a rate. What does a rate mean? Rate. So what I have right now, those are numbers. If I want a rate, what does a rate mean to start?
How often something happens?
Come again.
How often something happens?
How often something happens. So in statistics, how do we represent that?
In a fraction.
In a fraction, very good. What about your name?
Nikki.
Nikki. So Nikki, as in Nikki, not Nicole. That part I remember. So a fraction, how often something happens. So I can come up with something called a false positive rate. And if I asked you, well, what is the false positive rate? What would you say or do? Now, in a similar manner, one can obtain false negative rates, which is take a guess.
False negative over false negative plus true negative.
True negative,
Oh, is that, what is it called? What is TN? Total negative, total positive?
false negative over
Oh, true positive.
true positive. So false negative plus true positive. So there are different variations. So you could have 1 minus this value would simply be the complement. It will give you the true negative rate. One minus the false positive rate would be the true positive rate. If you look at the reasons that I pointed out, there are a whole lot of stuff such as false discovery, predictive value, precision, recall, accuracy. Different fields use different measures. In statistics, these two are important. I'll tell you why. First off, Nikki said that is a fraction. So is that fraction proper or improper? Let's test your algebraic skills. It's a proper fraction in the sense the denominator is always going to be bigger than the numerator. So you would get a number that's being 0 and 1, proper fraction. So that is a probability. If you have to take a guess, is it the probability of type 1 error or is it the probability of type 2 error? Type 1 error. False positive. Good. Over there, naturally, probability of type 2 error. In terms of notation, we call this alpha. That is beta. Good. You should have seen alpha before in 2023, but in 2023, they probably used a different 10 notes. Riley, you guessed it.
Yeah.
level of significance alpha. And in practice, we want the probability of making a mistake to be 0. Ideally speaking, I want no false negatives. I want no false positives. Is it realistic? No, it's always going to happen. So there is a trade-off between alpha and beta. In practice, one fixes the value of alpha and tries to increase beta. So alpha is fixed so that beta is maximized. What do I mean by maximized? Should say beta, 1 minus beta. Beta is maximized to mean I'm maximizing an error. We want it to be 1. In your previous introductory class, when you fixed alpha, what values did you choose? Typically. Yes, small here.
0.05.
0.05, 0.1, 0.01, that's the level that we always fix. And fixing that value, we want to maximize 1 minus beta. So we've got to give a name for 1 minus beta. 1 minus beta is what we call power. Some would call it statistical power. Alpha, we know that's level of significance. Oftentimes the confusion happens right here. And people start wondering, what is he talking about? Alpha is fixed, 1 minus beta is maximized. This is nothing like what I did in an introductory class. All I did is I plugged in a bunch of data and put it in a TI calculator, pressed a bunch of buttons, I got an answer. What is all of this? This is the job of a nerd like me. You know, in theoretical statistician would derive a test for a given scenario so that when that person fixes alpha at a certain value, 1 minus beta, or the power is maximized. 1 minus beta is simply a true negative, right? So we want 1 minus beta or the power to be maximized in order for a test to be valid. Some textbooks would refer power as just beta. I will check the textbook. You just have to connect the dots. So I've seen texts refer beta as just power. This is straightforward, better to understand. So 1 minus beta is power. In medical literature, alpha, beta, 1 minus beta, they have names. Do we know sensitivity? Yes. And if you did 1 minus alpha, you will get specificity. You don't have to know that in this class. I'm just mentioning it because in medical literature, you would see sensitivity and specificity. How specific is your test in determining a true positive? So 1 minus alpha will tell you what number of times you get a true positive detected correctly. No. That is your reference point, and from the reference, if you go far away, you are going to reject them. No. Going to consider one-sided case. I drew this picture last time. That shaded area is a probability. What is that equal to? Issue. Oftentimes people would say that is type 1 error. It's not true. It is the probability of making a type 1 error. So that is the value of it. Area under the curve is a probability. We denote it by the letter alpha because we're referring to what's positive. The shaded area in purple, what is that? This one last time. So it is the probability of making a type 2 error. In other words, in terms of a picture, does this make sense? Well, if you choose to reject the null and move on to or move over to the right, far away from the null, so that you reject the null, you have to do it with a probability that is alpha or less. Do you agree? So you're moving away. If you're rejecting, it has to be with that probability. The farther you go away from the null, the more confident you will get that the evidence is leaning more toward the alternative. Let's make. Yes. Now, the opposite view, well, you move this far, which means the type 1 error has gotten smaller. You reject the null. If you have to reject the null, in other words, there is a true positive, we must reject the null. The evidence supports the alternative, but you lean in this way and go toward the null with some probability, you are actually going for a false negative. Do you agree? Yes? No? Maybe. What's your name? Taylor. Taylor says yes. This line or above, you are going to reject. With what probability would you reject? 0.5, 0.1. So you would come this way. From the perspective of the alternative, if you rejected that probability. But when you have an effect and you go in this direction, you have to make that mistake with a very small probability. That is the purple part, beta. Yes, so there is overlap. I will demonstrate that in art. Good. Okay.